So here we're going to calculate molar heats of reaction, and we're going to do it from table. And the table is busy. It's complicated. So before we go there, let me come over here. Yeah, I already snapshotted this. And let's say what we're going to do is we're going to take the delta H of the reaction is going to equal the heats of formation of all the products minus the heats of formations of all the reactants. Okay, that's it. It's the products minus the reactants. Okay, the question is where are the heats of formation? And they're going to be in a table that's in that button right there. So before I do though, I'm going to set this up. I'm going to go, okay, I'm looking for nitric acid. It's going to be 2 times that, because I have 2 nitric acids. And it's going to be 2 times nitrous acid, okay, plus 1 times oxygen. But the standard heat of formation, these are from formation enthalpies. This is already in its standard state. That's going to be 0. I can prove it to myself. Suppose we forget that. And there's my nitrous acid. Here's my oxygen. And here's my nitric acid. I'm going to set all that up in my notes before I go, because if I just start and put this in my calculator, let me get this wrong. Let's come over here to the tables. And I don't want to take time in a video to show you how to find it. I guess I'm going to have to, aren't I? There you go. Thermodynamic properties. And these are my heats of formation. They're here. And there's a lot here. So I'm just going to scroll down. It's a really big table. I'm going to come down to nitric acid. It's probably going to be under N. Yeah, there it is. Okay. There it is, nitric acid. And it looks like it's gaseous nitric acid. So I could do aqueous nitric acid or gaseous. And it's not the same, right? Minus 133.4, it's gaseous I'm looking for. Minus 133.9, sorry. Minus 133.9. Come here. Minus 133.9. Okay. And then it's nitrous acid, which is also gaseous. You see that here? Got to be careful. There's 2 of them here. Looks like it's about negative 80. Minus 79.5. Okay, and suppose you forgot that oxygen, element O, suppose you forgot that the standard heat of formation of oxygen was 0, LMNO, nitrogen O, there it is, oxygen gas, and there it is, it's 0. Right, so you don't have to remember that that's 0, okay? So minus 80 times 2 is about minus 160, that's about minus times a minus, it's going to be about plus 160. And 2 times 133 is minus 2, or 134, I guess. I can't do that in my head. 68. 268. It's really the difference between those, right? It's going to be about minus 108. Let's go put that in our calculator and see what we get. I like calculating it out because if I'm way off, then I know, right? It's that minus that. Right. It's that minus that, and it's 2 times nitric acid, 2 times nitrous acid. Nitric acid was minus 133.9. Not sure if that's going to be okay. Let's do it like that. And this was minus 79.5. Let's go back over notes and make sure we got that right. Minus 133.9, minus 79.5, and it ought to give me close to 108, negative 108, and it does, minus 108.8. It says to the nearest kilojoule, so I'm going to say minus 109. Okay, so big deal here. It's the products minus the reactants. Got to go find those in the table. Make sure you get the states right, and do this a few times, and you'll be good. Good luck.